In this video, we'll take a closer look at the curve data table found in many MyAssays.com reports and demonstrate how it can be used to efficiently evaluate accuracy and precision across the standard curve. I have open an example protocol, the MyAssays Human Anti-SARS-CoV-2 IgM ELISA kit, and I've already calculated my results. This assay is representative of a pretty standard assay with standard, blank, and unknown sample types. A blank correction is performed, followed by a 4PL fit, and the sample concentrations are calculated using the curve fit equation. Maximizing the PDF report, you'll see first the standard curve chart and the evaluations table displaying the curve fit parameters and R-squared value. Below this, you'll see our curve data table. This table provides additional information about the standard samples and their precision and accuracy. Precision is a measure of how close the replicates of each standard are to each other and is represented by %CV. The %CV column here shows the difference between the replicates calculated or backfit concentrations. The higher the %CV, the bigger difference between the replicate values. The % accuracy is a measure of how closely the obtained concentrations match the theoretical or defined concentrations for each standard. The closer to 100% accuracy, the closer the obtained concentration matches the defined concentration. If we look at standard 7, the defined concentration is 25, and the obtained concentrations of 25.967 and 24.954 are quite close to 25, and the % accuracy shows 101.843, indicating a good accuracy result for standard 7. Looking at standard 1, the defined concentration is 0.01, with calculated concentrations for the replicates 0.06 and 0.072, with an average of 0.66. This results in an accuracy value of 660%, which indicates very poor accuracy. In general, where the curve is closer to a horizontal line, the accuracy is likely to be poorer because a small change in y results in a large change in x. You'll notice in this table the light red and light green highlighting. This helps you see at a glance which standards have both %CV and accuracy within acceptable limits. The default limits for acceptability are 20%, so if the standard shows a %CV less than 20 and a % accuracy between 80 and 120, the row will be highlighted in light green. If either or both the %CV and accuracy are outside these limits, the row will be highlighted in light red. We can see in this example that standard 1 does not meet the 20% acceptability requirements, because while the %CV is less than 20, the accuracy is well outside the acceptable range. Let's take a look at an example where one of my standard wells may have been contaminated. I'll go back to my Measurements tab and quickly contaminate one of my wells and recalculate. Looking at my interactive chart, I can easily see which standard replicate is an outlier, and because of this replicate, we can see the curve fit line has essentially been pulled up a little higher, so I'll expect a larger number of my standard samples to show poor accuracy as they no longer fall on the fit line. Maximizing my report, I can see now that standards 1 through 6 are all highlighted in red. Their %CVs are not a problem, with the exception of standard 5, which is the standard with the contaminated replicate. The issue here is that all of the accuracies are outside of the acceptability limits. So in the case of this run with an obvious outlier, I'll simply open the interactive chart, click on the point I'd like to remove, and recalculate. Now when we look at the interactive chart, the standard points are much closer to the actual fit line, and taking a look at my report, I can see the flagged point here in well E1, and my curve precision and accuracy are looking much better. I'm going to quickly reset my data for one more example. I'll re-include the flagged point and update the data so that E1 is no longer contaminated. There are some cases where for the accuracy you might encounter an infinity symbol as a result. This can occur with a 0 standard, so I'll open my standard concentrations tab and update standard 1 from 0.01 to 0 and recalculate. Opening the report, you'll see standard 1's accuracy result is reported as infinity. This is because the accuracy is calculated as 100 multiplied by the obtained concentration divided by the defined concentration. Because we define standard 1's concentration as 0, dividing any value by 0 will return an infinite result. The curve data table is a great tool to help you quickly assess your standard precision and accuracy across the range of the curve, providing convenient highlighting to help you identify any issues your standard samples may show. If you have any questions about the curve data table in MyAssays.com's data analysis tools, please email us at support@myassays.com.